Good morning, all. I'm from Sai Vidya Institute of Technology, Professor Srilata, who's taking the computer organization subject. In previous video, you had seen the Booth algorithm. Okay. In this video, we'll see how fast multiplication is done. That is, multiplication is done faster in the process within the processor. Okay. So Booth algorithm reduces the multiplication time taken if there are more continuous number of ones and continuous number of zeros. So how can the multiplication made faster by using two techniques? We'll see one of the technique in today's video. Okay, there are two techniques, that is bit pair recoding of multipliers, and the other one is carry save addition of summons. Okay, we'll see in today's video about the bit pair recoding of multipliers. Now, you had seen the previous video where Booth algorithm was discussed. Okay, so the multiplier is converted to Booth code, and the Booth coded multiplier is used for the multiplication process. So it is very helpful when there is continuous ones and zeros. Okay, so suppose the multiplier is 0 1 1 1 1 0. Okay, if this is the multiplier, it reduces, if using Booth code, it reduces to, so Booth recoded string is Booth recoded string is 0 minus 1 0 0 0 plus 1. Okay, so now this is our new multiplier according to Booth algorithm. Okay, so here there are 6 bits. The multiplier actually is of 6 bits, and now the Booth multiplier is also of 6 bits, but there are only two ones which has to be multiplied. Multiplication happens only with ones. With zeros, it is always 0. You had seen in the Booth video. Okay, in the Booth multiplication video. Now, uh, so this multiplier is paired according to bit pair recoding technique. According to bit pair recoding technique, what happens? How many ever multiplier bits are there? It is paired into two. Okay, each two bits are paired, and now the number of multiplier bits reduces by n by 2. Okay, if there are n bits which is for multiplication, then the multiplier bits reduces, the count reduces by 2. Okay, so what is the advantage of bit pair recoding? If the multiplier bits were actually 6 bits, then using bit pair recoding, the multiplier in the bit pair recoding, the multiplier bits will be only 3. 6 by 2 is 3. Only 3 bits are present. Okay, so multiplication has to be done by using only this 3 bits. Now, how to reduce the 6 bits into 3 bits? Okay, so that we'll see in this particular video. Now, this is the Booth code which we have got. Okay, now it has to be reduced to 3 bits using bit pair recoding technique. Okay, bit pair recoding. So how it is done is, we use the technique like 2i plus j. Okay, 2i plus j. So 2i plus j means, suppose this in this group, in this pair, this particular value is I and this is j. Okay, so 2i plus j in this pair is 2 into I, that is minus 1, plus j, which is 0. So you get minus 2. So at this particular location, the value, instead of minus 1 and 0, the value is minus 2. Okay, coming to the next pair, this is the I, and the next to 0 is j. Okay, so this is I and this particular bit is j. Again 2i plus j, that is 2i is 0 and j is also 0. The value which you get is 0. So the value which I get is 0. Okay, so here it is 0. In the next bit pair again, in the next bit pair, so this bit stands for I and this is j. So 2 plus 1, 2 into 1, that is plus 0. 2i plus j, okay, is 2. So you get here the value 2. Okay, now the bits which were in the 6 bits were there for the multiplier is reduced to only 2 bits. This becomes plus 2. It is plus 2. Correct? So it becomes plus 2. So this is the multiplier bit which is formed. Okay. Now in bit pair recoding, always when you are computing, you convert it into booth code first. Okay. And then produce the bit pair recoded. Okay, recoded bit, and this will be multiplied by the multiplicand. Okay, now what should you multiply when there is plus 2 and when there is minus 2 and plus 1 minus 1? Okay, such cases will happen. So we'll see that. Okay, yes, bit pair recoding halves the maximum number of summons, or the partial products which is formed is halved. Okay, so we'll see the multiplication process, how it should happen here. Okay, so this is the process which you had seen. Yes, you can see this is by using Booth algorithm. Okay, this stands for minus 6 using Booth algorithm, and that is converted into this bit pair. You can see the number of rows which is reduced to. Okay, here it is so many rows, and here it is only 3 rows. Okay, now we'll take one example and then solve the algorithm. Okay, so I'll take minus 13 into 11. Okay, so what is minus 13? You know that plus 13 is 1101 is plus 13. So as it is a positive number, I'll put a 0 here. Okay, so this is plus 13. Now I have to find what is minus 13. All of you know how it has to be converted. Okay, to find minus 13, find the 2's complement of plus 13. So 1's complement of this particular binary bit pattern is 10010, plus 1 gives the 2's complement, that is 11001, and this is 2's complement of plus 13, which is nothing but minus 13. Okay, now this is our multiplicand. Okay, so 10011, which is nothing but minus 13, is the multiplicand. Correct? Next, so 11 is 0, 10, what is 11? 1010 is 10, and 1011 is 11 plus 11. Now I have to find the booth code of it and then the bit pair recoding. Okay, so booth code of this particular value, that is 01011. All of you know how it has to be done in booth code. What do we do when I want to find the booth code? Add a 0 at the LSB. Okay, so 0 and then 1, it is minus 1, continuous ones is 0. Okay, 0 and previously 1 is plus 1, 1 and previously 0, that is start of 1 is -1, and this is +1. Okay, so you get the booth code. Now, to get the bit pair string, I should pair this. I pair the first 2 bits. I pair the next 2 bits. Okay, there is no bit for pairing here. In such case, add a 0. Okay, in such case, add a 0. I have added a 0 for pairing purpose. Fine. Now, find the bit pair recode. Bit pair recode. Recoded bit. How do I find? Yes, 2i plus j. Okay. Now, in this position, I get the multiplier. 2i plus j. This is I and this is j. Okay. So 2i plus j. Here I get -1. Again for this is I, this is j. Okay. So 2 into -1 plus 1. I get -1. So I get -1 here. And here, using the same technique, I and j, I get +1. So this is the bit pair recoding. Now the multiplication has to be done. Okay. So for multiplication, note down this. It is -13, which is the multiplicand. And this is the multiplier. Okay, note down these values. The same I'll write down here. So multiplicand is 10011. This is the multiplicand. 10011, and the multiplier, that is bit pair, the recoded multiplier is -1, -1, and +1. Okay. Now, how the multiplication has to be done? When there is -2, when the value is -2, okay, if the value is -2, what you are supposed to add is put a 0 at the LSB, okay, and then 2's complement of multiplicand. Okay, if it is +2, add a 0 at the LSB and then the multiplicand. Similarly, if it is -1, you find the 2's complement. Remember, whenever there is negative, it is the 2's complement of multiplicand, and when there is +1, it is directly the multiplicand directly. Fine. When it is 2, add a 0 at the LSB. In both the cases, add a 0 at the LSB. If it is -2, the 2's complement of multiplicand. If it is +2, then directly the multiplicand. Again, -1, 2's complement of multiplicand, +1, directly the multiplicand. Okay. Now, this is the multiplicand, that is -13. Okay, 2's complement of, now for this -1, what should I put? If there is -1, I should put the 2's complement of multiplicand. Okay, what is the 2's complement of -13? And just find the 2's complement of -13. All of you know that if the I get the negative number of the whatever value, correct? So I'm finding the 2's complement of this particular -13. I should get +13. Okay, so 1's complement is 0, 1, 1, 0, 0, +1. I get 0, 1, 1, 0, 1. That is +13. And this is 2's complement of multiplicand. Okay. Now coming back here, I have got minus. I have to multiply by -1. So when there is -1, I have to put 2's complement of multiplicand. Okay. So 2's complement of multiplicand is 1, 0, 1, 1, 0. Fine. As I have told, now this is 5 bits operand. So the product will be of 10 bits. Do the sign extension. Okay, what is the sign? It is plus 13 value what I have written there. Okay, it is plus 13. That is the 2's complement of multiplicand is plus 13, means I have a 0 here, so it is a plus value. Sign extension, put zeros. Okay, so 10 bit I have to frame already. 5, 6, 7, 8, 9, 10 bits. Okay, next I have to multiply by minus 1. Okay, now from which position? This is at the third position. Okay, so start at the third position, and at the third position again here it is minus 1. So 2's complement of multiplicand, so it is 1 0 1 1 0, and then sign extension. Sign extension is 0 0 0. Okay, next I have to multiply by plus 1. When there is plus 1, it is the multiplicand directly from the fifth position. Okay, this is the fifth position. So from the fifth position, it is 1 1 directly the multiplicand. I'm multiplying by plus 1. Okay, so when I'm multiplying by plus 1, it is directly the multiplicand. Okay, so put the multiplicand 1 0. Okay, 1 1, sorry. So the multiplicand is 1 0 1. Okay, so multiplicand is minus 13, that is 1 1 0 0 1. Sign extension of this, what is the sign extension? I get the value 1. Okay, now do the summation. The summation here, I'll get the sum. I'll get the sum as 1 0 0 1 carry, 0 1 carry, and 3, that is 1 1 3. So 1 1. Okay, 0 and 1 1. Fine, now this is the value what I have got. So from this value I know that it is a negative value which I have got, because the MSB is negative, is 1. Okay, and to find the magnitude of it, I should find the 2's complement of this product. Okay, now find the 2's complement of this product. I'll just find it here in the working. Okay, so 2's complement is 0 0 1 0 0 0 and 1 1 1 0. Okay, that is 0 0 plus 1. I get 0 0 1 0 0 0 1 1 1 and 1. Okay, now check the value what it is. This is 2 power 0, 2 power 1, 2 power 2, and 2 power 3, 4 5 6, and this is 2 power 7. 2 power 7 is 128, plus 2 power 3 is 8, plus 2 power 2 is 4, plus 2 plus 1. I get, do the summation of this, that is 130 plus this is 12 13, so plus 13, I get 143. So this value is 143. Binary value is 143 what I have got. Check whether this is correct. The multiplication of this, is it returning minus 143? Yes, 11 3s are 33 and 11 1s are 11, plus 3 is 14. So I am getting 143. Okay, and you are getting the bit pattern also as minus 143. So this is the bit pair multiplication. Okay, my bit pair recoding. And also there is a table which is given. Okay, using this table also you can frame the bit pair directly. Fine, you can frame the bit pair directly using the table. So we have found here of. Okay. So this is the process of bit pair multiplication. Even for using the table as I had done in the class, you can find the bit pair directly without using both table. Okay, so this is about bit pair recoding. Thank you.